Okay, so today we're going to be adding co-functions or co-ratios to our cos diagram and to our simplifications. And I just wanted to use a right angle triangle to show you or try and explain your co-ratios to you. So if you look at this triangle that I've drawn here, ABC, if you remember from last year, if I had angle C, this AB, let's just make this red, AB would be the opposite, CB would be the adjacent, and AC would be the hypotenuse. Okay, so that's for theta. Now, if this is a right angle triangle, then angle A would be equal to 180 minus the 90 plus the theta in the corner there. Okay, so that would be the sum of the angles in a triangle, which means that angle A would be 180. We're going to distribute that negative in there. And then these are like terms, so angle A would be 90 minus theta. All right, so in angle A here, I'm going to write 90 minus theta. I'm going to make that one green. And then for 90 minus theta, this would be the adjacent side, this would be the opposite side, and then this would obviously still be the hypotenuse. Okay, so let's look at, if I said what is the sine of theta, we would say it was opposite. So katoa, sine is opposite over hypotenuse. So for theta, the red one, sine would be AB, the opposite, over the red one, hypotenuse AC. Okay, and if we looked at the cos of 90 minus theta, okay, so cos is adjacent over hypotenuse. Okay, now 90 minus theta is a green one. So for the green one, the adjacent is AB, and the hypotenuse is still AC. Okay, can you guys see that these are exactly the same? So that tells me that if these are both AB over AC, then the cos of 90 minus theta has to be equal to the sine of theta. Okay, they're equal to each other. And it works the same if I said to you, what is the cos of theta? Cos is adjacent over hypotenuse. So cos of theta, that's a red one, adjacent, BC, over hypotenuse, AC. And if I looked at the sine of 90 minus theta, okay, now you're looking at the green one, sine is opposite over hypotenuse. So for the green one, opposite is BC, hypotenuse is AC. And again, these two are the same. So that tells me that the sine of 90 minus theta is equal to the cos of theta. Okay, so these two things that I've put in puffy clouds here are called your co-functions or your co-ratios. And what we need to remember is if we have a 90 minus theta, that your cos will change to a sine, and your sine will change to a cos. So that's important to remember about that 90. Okay, so I'm going to add the 90 minus theta and the 90 plus theta to my cos diagram. All right, so 90 minus theta would be a first quadrant angle. So if you can imagine, if you went 90 degrees, you'd end up here. And then minus theta, remember when you do a negative angle, or when you subtract, you're going to the clockwise direction. And theta is always, you can imagine just moving half a quadrant. So if I went 90 and then back half a quadrant, I would end up in the first quadrant. So 90 minus theta is a first quadrant angle. Okay, so that's first quadrant. 90 plus theta, okay, it's also a co-ratio or a co-function, but this time we're going to go 90, there I've ended up here, but now I'm adding, so I keep going anti-clockwise, half a quadrant, so I'm moving into the second quadrant. So you need to now remember that we've got these two co-ratios. 90 minus theta is a first quadrant angle, and 90 plus theta is a second quadrant angle. Okay, we only use this with sine and cos. We don't, tan is not something that we cover at school. So what we're going to do is we're going to write down, quickly look at these. If I get the sine of 90 minus theta, we know that sine 90 changes to cos. Okay, this is a first quadrant angle. Okay, so sine in the first quadrant is positive, so it goes positive cos, and then you go back to the acute angle there. Okay, cos of 90 minus theta. Again, it's a first quadrant angle. Cos in the first quadrant is positive, so we go positive, and then the 90 changes the cos to a sine. So you've just got to remember that that 90 changes this from cos to sine or sine to cos. Okay, now what about sine of 90 plus theta? Okay, we've just said that 90 plus theta is a second quadrant angle. Sine in the second is positive, so we're going to go positive, which you don't need to write, cos theta. Remember, 90 changes sine to cos. And finally, the cos of 90 plus theta. Okay, we just said 90 plus theta, second quadrant angle. So now we say cos in the second is negative, and then the 90 changes cos into sine. So those are the ratios that we're going to be using as co-ratios. You don't need to learn all the signs. You can see that I worked out what sign it was by the quadrant. You just have to remember that cos 90 would change to sine, and sine 90 would change to cos. Alright, but we do need to know where they are in our cos diagram. Alright, so let's try some. I've just put a little cos diagram on the side here now. I've put the 90 plus and the 90 minus theta in red to remind me that those are going to be special. They're going to change from sine to cos or cos to sine. Alright, so we still do exactly the same as we were doing yesterday. We first start by identify the quadrant. Okay, so can we find it on here? Yes, well 90 minus theta is a first quadrant angle. What I normally do is if I see a 90, I put little exclamation marks on top to remind me that that's going to be a co-ratio. Okay, so underline it, do something to remind yourself that this is going to have to change. Sine, that's in the first quadrant as well. Don't need to worry about that. Cos in the first quadrant. Cos theta, it's already been reduced. So again, cos 90 minus theta, I'm putting little exclamation marks there to remind me that something is going to happen with a co-ratio, but it's still the first quadrant. So all my ratios are positive in the first quadrant, so I don't have to worry about any signs really. 1, 2, signs and reduce. Okay, so what's going to happen here is because this is a first quadrant angle, everything's going to be positive. Sine 90 minus theta, those exclamation marks remind me that sine has to change to cos of theta. So you change sine to cos because of the 90, and then you reduce it to the acute angle of theta. Alright, sine theta, it's a first quadrant angle already, so we just write it again. Remember, if it's a first quadrant angle, we just rewrite it. First quadrant angle. But this one's a first quadrant, but it's got the exclamation marks because we still have to change it from cos to sine because it's a co-ratio and we get sine theta. Okay, now we're going to do our simplification. And we simplify with our algebra. Okay, so cos, because it's one term over one term, cos will go into their ones and into their ones. Sine will go into their ones and into their ones. So what do we have? We have 1 over 1, which will give me a 1. Okay. Here's another example. I've added extra ones in here. So we've got some negative angles, co-ratios, angles that are bigger than 360. So here's my cos diagram again. And we start once again, identify the quadrant. And if we can't identify the quadrant, then we have to add or subtract 360 to try and find the same numbers on our cos diagram, which quadrant it is. All right, so 180 minus x, well, I can see it's there in the second quadrant, so this is a second quadrant angle. 90, cos of 90 minus x, all right, so 90 minus x will be first quadrant, but I'm just reminding myself that this is going to be a co-ratio, okay? We have to change that. Tan negative x, well, negative theta is in the fourth quadrant, so I can see it. There's no 540. There's nothing that looks like 540 plus x on my cos diagram, so I know I need to subtract 360. And remember, if this is a positive 540, you need to do the opposite. So we need to minus 360 from it. Okay, sine of 90 plus x, well, 90 plus x, same as 90 plus theta, it's a second quadrant angle. But again, I have to remind myself that this 90 is going to change sine into cos. Okay, so when I subtract that 360, I'm going to end up with, I'm just going to write this again. This is going to be the sine of 180 plus x, and this is going to be still the same. Okay, so I'm just subtracted that 360, going back and putting all my things on. So we said this was second, this was first, but I have to remember about the co-ratio. Fourth, now I can see this one. 180 plus x is third quadrant. 90 plus x we said was second quadrant, and I made myself aware that I had to change the 90. Or sine to cos because of the 90. Okay, so we've identified all the quadrants. So next I'm going to find the sine and reduce it. Okay. So cos in the second is negative, so we do negative cos of x. Okay, cos in the first, see how I'm saying cos in the first is positive, but now that 90 changes cos into sine of x. Tan in the fourth, okay, is negative. Tan in the fourth quadrant is negative. Tan of, reduce it to the x. Sine in the third is negative. Reduce it to the x. Now again, I've circled my 90 with my exclamation marks because I have to remember that instead of writing sine again, I have to change it to cos because of the 90. So sine in the second is positive, and then we change sine into cos and we write the acute angle. Okay, so you check whether this sign, what is this doing in the second quadrant? Okay. Okay, and then once we've done that, sorry, my pen didn't change. We're going to simplify using our algebra. And we have, again, one term over one term, so I may cancel. So that sine x goes into their ones and into their ones. Cos x divides into their ones and into their ones. So there's nothing to divide with the tan x. So let's multiply now across the top. Negative times a positive times a negative gives me a positive. 1 times tan x would give me a tan x. At the bottom I've got negative 1 times positive 1, which gives me a negative 1. And then we're going to finish by saying a positive over a negative gives me a negative, and tan x divided by 1 would give me tan x. Okay, so everything was the same as we were doing yesterday and the day before. We just added this whole 90 idea, and you have to remember that if you see a 90, make yourself aware of it, because you need to change sine to cos or cos to sine.